Oops, hold on. You won't be staying for long because of school. That's fair. I'm sorry, I just had to break the intro to say hi, Infotrix, and hi, and bye, good luck. Hi, Mr. Based. Hi, welcome. Welcome. And here's the thing. I've had just the dang greatest idea if it works out. If it doesn't, then it's not going to be a great idea. It's going to be a mid idea at best. Allow me to explain. You see, for the chemistry video in 3 weeks, I will have to make a thing. Hi, the Funky Corgi. Hi, welcome. I'll have to make a thing, a thingamajig thingamabob, because I know that Flame will just use his power of magic rocks on me if I don't. I will have to make the electronegativity thingamabob. So basically, it's simple. You put a metal ball on each s orbital, you put like a hourglass shape on each p orbital, and then basically in every single place where something is electronegative or positively charged, like normal people would say, then it's more blue. In every single spot where it's less electronegative, so more negatively charged, it's more red, and that represents the polarity of electron clouds. The only problem is I don't have a single tool for this. I've tried an Avogadro, it failed, and so I thought I could just make one. And my idea basically was, I can't do it with shader nodes because I just don't know how. It's really difficult because shader nodes measure position in like an odd way. However, what if I were to do it with geometry nodes? The only pickle there will be Blender metal balls in geometry nodes. I know that what I'm saying is hyper specific to Blender, and everyone who doesn't use Blender has no idea what I'm basically saying, but basically I'm trying to make a tool which... Is there any walked away with geonodes? To at least use them as instances. Nope, not straight away. Only possible in Eevee as render and... Oh my goodness, really? There's a workaround though. I'm all for it. If you need to explain the image sequence, Blender updates metaballs and shows them. Okay, so you... Oh my goodness, it's gonna be awful. Oh, this is gonna be awful. Absolutely. I mean, I could make it work, S orbital, pun intended. If we have orbitals like this, if we have an S orbital, right, and then if we have a... Piss off. If we have a P orbital, and then P orbital will be kind of like an S orbital, the only difference will be that will be an hourglass. Oh yeah, right, I can't just have them disappear, can I? Ah, it's even more annoying. So, Z up by like 2, Z down by like -4, and U up by like 1 and 0.5 of scale. This is only a simple one for reference, -1 and 0.5 for scale. There we go. Pissed. Damn it, my muscle memory keeps pressing. Okay, so now we have an S orbital and a P orbital, and if we now... You know, no, I'm screwed. I'm just gonna save it somewhere because my muscle memory keep pressing Ctrl S. Temp files, why not? Temp files, electronegativity. There we go. There we go. And then if we add a default cube, if we add geometry nodes, if we go into geometry nodes, if we get geometry node editor, if we add a new, if we dismount this one, if we do the collection info, and if we pick the collection to be P orbital geometry, then... Haha! It kind of worked, transform. Oh no, it doesn't. Okay. Well, shucks. Okay, I see the problem. I certainly see the problem. Hi there, Remco. Is this a live demonstration of witchcraft? We will need to summon at least 3 separate demons to achieve the desired result, yes. Hi there, Remco. Remco, there is a pretty solid chance, because I'm starting this live stream to make geometry notes for the organic chemistry video, but there is a pretty solid chance that we'll just end up doing quantum mechanics today. Or rather, planning video for quantum mechanics, or maybe researching quantum mechanics. Wave packets might as well. We're talking about bias, just approximating at the point particle, making your life happier. No, the problem is, no, I'm trying to make an electronegativity graph, which is a really cool graph. I absolutely love it. The only problem is, how did you even achieve that? How did you even achieve that? That would be kind of what I'm looking for. Well, I would have to modify it heavily, but volume cube node. I mean, this is a metabole volume cube, real. Yeah, but how did you achieve the color? Mesh line points to volume. Volume to mesh. Oh! Volume to mesh exists. Volume to mesh exists. Cancerbad might be the funniest name. Thank you. Thank you. It took me a really long time to steal it from Atomic. Cancerbad. Good. The true display of Maker's creativity. This is... Hold on. This is genius. This is so genius. So basically, here's what we can do. We can make orbitals like this. Whatever, misspelled, as if I care. And we can create the s orbital, which will look like this. Then we can add in a UV sphere. This will be our p orbital. And in order to make the p orbital fully, we just want to extend this up. Object geometry to origin. There we go. Extend this even higher up. Well, actually, I feel like it just more space between them. There we go. Geometry to origin. Then slice in the middle, merge. Two more good slices, I guess. And then... No. I should have just given more slices from the start. Yeah. Like this many. That should be fine. There we go. P orbital. Oh, that is so unbelievably clever. And then basically, we hide them. And in geometry nodes right here, we take object info. Oh, this is phenomenal. P orbital. There we go. Then we take another P orbital, transform geometry like this. We rotate it by join. Oh my goodness, this is gonna save me so much time. They're like pills that keep me on theoretical physics. Physics itself is a drug. The way you talk about physics, it's insane. No, guys, I swear, just when you travel really fast, time changes itself. Physicists are really just delusional. Same Remco from Discord. Yeah, that is the Remco. That is the Remco. Remco's got a special collar in Discord and on streams. This is the physics Remco. Remco the physicist. And so right here, if we then mesh to volume like this, and then the volume to mesh. Oh! Hold on. Oh, threshold last here has to go up. That's odd. No, wait. Never mind. Oh, is this the problem? Oh my goodness. That's... hold on, and now if we move it around, it's gonna... I'm assuming it's gonna absolutely crash everything I have, because it's gonna be very demanding of my PC, but... Oh. Yeah, and every now and then we get artifacts, but I mean, oh, what you gonna do? Grid amount... Oh. Okay, well, maybe not that many. Size... is 0.1. Okay, no, it's not the smallest. Well, I don't want that far because that's a bit too far. That's a bit too in depth. Let's do 5. There we go. Adaptivity. Yeah, increase it to 0.1. Why not? Oh, hell yeah. 5. Oh, Hell yeah! Look at that! Oh, that rotation not gonna do nothing. Look at this! Now we have kind of like almost. Don't mind the artifacts, okay? That doesn't matter. His profile image is very different, which makes like a different person. This will be my wolf personality. Physics itself is a drug. It really is, though. You can do also assign material by index. That won't matter, because the thing is, the reason why I want to do it in geometry nodes, why did I close it off? The reason why I want to do it in geometry nodes is because right here I can do a store named attribute, and it's basically so much easier to just hold on, color and face. It's so much easier to do operations in geometry nodes than it is in any other place. So right here we can just crank it up to be a bit more white and transparent to give us some contrast. There we go. And then right here just give it a nice and simple material called electronegativity. There we go. And then attribute name color, and then color into we don't have to put in the mission, just base for now. We're trying to build a skeleton. The nice looks will come later. Is that a p orbital or something? It is indeed, and I'm trying to make it, pun intended, so that it will basically be able to get the electronegativity only based on certain underlying empties, for example. So if we take an empty, like so, let's say, like this, and we want it to be red, because why not? Then right here we can mix color, because once again, why not? It will be, for now we're doing a simplified version, so might as well. Like so, and then object info. I'm gonna have to do it in a way so that it measures the distance to whichever. It's not gonna be easy, I can tell you that much. I don't know a lot about quantum mechanics or Blender. I just found it so entertaining to watch you get so surprised. The thing I can't understand at all. I mean, it's fine. I get it. This is extremely specific what I'm doing basically. But oh, how would I get a point? How would I get it at each point? That's a good question, actually. Oh, that's a pickle. That's certainly a pickle. I would need the distance between each point and So coordinate of the texture. I could do it with this for now, I guess, but that's gonna be way off. Vector math. I should also play some music, but for now we're just gonna add in distance, like so, factor, location to the empty. Or red rather. And like this, and if we do it this way, then nothing is gonna happen. Why did nothing happen? I see the problem. The attribute isn't oh yeah, because I forgot about material. I'm such an idiot. There we go. Now it's going through this a bit. And then math subtract 1 minus this. Actually, we can keep increasing it until we reach the point where... Oh yeah, it's always gonna be constant. I'm an idiot. Okay. Cool, we got somewhere. You can, to position, then take the length. To position of what? Because what I'm looking for is I'm looking for some kind of node that will give me the geometry of, well, the position of each face, basically. Or rather, not face, only each point ideally, but that's more of a shaded node kind of thing. So what I want is well, this seems kind of correct at the very least. Position of every point. Yeah, hold on. Let me first get some music playing. Now let's add some more music, why not? There we go. Position node, you say? Oh, hell yeah. This will be tricky though. What is he doing? I am so glad you asked. And Nico, I'm doing something that will be rather difficult to achieve. Because this one, I've already did that in the past. This kind of thing I already did in the past. The only difference is I haven't done it in geometry nodes. I did it with metaballs in shading nodes. The reason why I'm doing it in geometry nodes is because this one will be significantly more difficult, but basically what I'm trying to do is electronegativity render of a molecule. I'm trying to achieve something like this. The only problem being that we will have multiple points of positive. So for example, I could achieve it, I guess. Let me think about it mathematically for a second. Right now, value of 0 represents... Value of 0 represents blue, value of 1 represents red. That will not do. That will simply not do. What we want instead is we want -1 to be blue, 1 to be red. That would be better because then we can use 0 as our in-between. So to test that out, we'll take a sine. To test out how to make it work, we'll take a sine. I should learn by now how to do this whole thing. There we go. And so sine goes from -1 to +1, so we just add 1, divide by 2. When I made the video, making animations using math, I wasn't joking. That really is how I make them. I know you could do it without geometry nodes, I mean without this much math, but I prefer to do it this way. I'm just used to it. Until now. Yeah, so there will be a lot of things which y'all will probably not understand, but that's not because they're difficult, only because it's just Blender, that's it. They're not difficult, that's what I'm basically trying to say. Like, this node setup is really trivial, it really is. The most bare bones trivial. Try using a color ramp. I don't really have a need for it. I don't really have a need, this already will do the trick. See, you're doing a lot of Blender animations, that is my job! And so now basically what we want to achieve, now that we achieved that, we can remove the sign, we don't care for it anymore. And basically... We want multiple, well, these aren't red, let's call them minus, because why not? Now what we want is we want all of it to be white. Right, shade the object smooth. That's for later. That's for later. That's not important for now. I don't understand, but I know H2 open is an FSP3 hybridization. First of all, we want all of it to be white, which means distance itself will not do. Distance will tell us... Oh, I think I've got an idea. Oh, that could be clever. That could be... It's gonna be kind of idiotic, but it could be clever. Basically... Oh, that would be the dumbest possible thing. I love it. Basically, we could save the value. Because here's the thing. We'll have certain empties which will be minuses, and we'll also have certain empties which will be pluses. So right here, we're gonna have plus... plus, plus, like this. Certain empties which are minuses, certain empties which are pluses. And we want each minus empty to be red, each plus empty to be blue, or the other way around, doesn't matter, just this whole thing, and all the rest we want to be white. What if we hop in and we encode that information in the size of the empties? So right here, and then we could, this could work. I don't know if size or rotation would be better. Because here's the thing, size and rotation are meaningless for the empties, basically. At least the way we're using them right now. So if we take the scale of each empty, and if we check math, or separate XYZ, doesn't matter, it's uniform in all of them. if we take the x, for example, and check if it's greater than 1.5, then this will return a 1 if it's greater, and 0 if it's not. So what we do now is we take math, we multiply it by 2, now it will return 0 or 2, and then we subtract 1 from it, and now it will return 1 or 0, and then we math multiply it right here. And one last thing, which is pretty important too, it is to math hyperbolic tangent. Like this. Now we multiply both these together. I've achieved the exact opposite result of what I wanted. Are you actually in a financial struggle? Is a joke? I am. Depends how you define financial struggle. Like, I'm not going homeless yet. Yet. However, if nothing will change, then I will have to stop doing YouTube full time and then just stop making videos, because I will go homeless. But it's fine. I got a couple of months. I can get there. You don't need to separate the red and blue. You don't need to separate the red and blue side. Then walk like normal people do. I'm trying. Well, I'm trying to this way. Okay, there we go. Now do we have this? If we get it to be smaller, everything turns blue. That's bad. Because of the distance now, isn't it? Oh, wait, I'm an idiot. That's not what I'm supposed to do at all. We do want the distance to fade out. Hold on, let me think about this for a second, maths. So basically, the distance is increasing. We don't want that. Instead, we want it to look more like this. And hence, if we want it to look more like this, that means first of all, we need to invert it to go into the negatives. Then put it through hyperbolic tangent. Invert, put through hyperbolic tangent. So this is idiotic right here. Instead, subtract 1 minus, put it through hyperbolic tangent, and then add 2, add 1, divide by 2. There we go. Now everything is white, except whenever this goes, it's slightly reddish, and if we make it smaller, it's bluish. I am a genius! Genius! Absolute, that's so clever. What I've done here, it's so clever, because now we can take this, and we can freaking group it, and then right here, oh my goodness, I feel so clever. Get charge. That's because right now, we can just add however many we want of these. We can add another one, this time with a plus, like this. Look at that! Oh my goodness, okay, this is amazing. I finished it so quickly. There we go. Oh, that's phenomenal. That's absolutely phenomenal. Now we can work on the cosmetics if we want. We've finished the basics, we can work on the cosmetics. So we can basically change it so that it's going from red to 0.5 to blue through green, for example. Because why not? I do believe that's how usually it goes. There we go. Why isn't this working all of a sudden? Huh? What happened? Why are you still grey? Uh-oh. How come it's not working all of a sudden? What? I'm sorry. Is the color? I mean, I could always just plug in the color itself, I guess. Do you prefer Blender for Science animations? Yeah, I'm used to it. That's mostly why. We can also just plug in the float itself right here. It doesn't matter. Might as well copy the color ROM too, I guess. Internal clipboard empty, of course it is. Absolutely, of course it is. There we go. Sweet. Dark magic is all I see, yeah, exactly. It's always just dark magic in my videos. Now what's really nice too is we can go into these nodes and we can change some things up. So for example, we can change this up and increase how much it matters for each one of them. So what we could do is we could actually assign that to a value. So right now the X scale is dependent for, oh, this is so clever. This is so unbelievably clever. The X scale of the empty tells us the charge. The Y scale could tell us the size. So now if we scale it on the Y axis, it's getting bigger or small. I am sorry, but this is I've done an amazing job. In half an hour. Right before the stream I took a shower and I was just thinking about how am I gonna make these. And I realized that if I make them in geometry nodes, it's gonna be so much easier. I'm wondering, how accurate are the videos when it comes to the subject matter? I would say they're pretty accurate. Depends on the respect. The thing is, Tita, I go really far to make sure that I don't spread misinformation. I do check in with people I consider experts. I have to say I consider, because even though Flame is literally doing a PhD right now, he still doesn't consider himself an expert. A professional researcher who's actually doing a PhD as we speak doesn't consider himself a researcher, so I guess I'll have to wait. Doesn't consider himself an expert, so I guess I have to wait 4 more years till he finally becomes a doctor, and maybe then he'll finally accept the fact that he's an expert. So I am going through a lot of trouble to make sure. However, at the end of the day, I do make mistakes. Every single time I'm unsure of anything, I try to make that as clear as possible. For example, with the rotation of the triple bond. I did say that I had conflicting sources, because I did. Or another one, when it comes to the naming in the organic chemistry video, I did specifically say that there are multiple names for molecules. And I will not give you the preferred one because IUPAC is really, really, really complex. That was mostly there as a background for the rest of organic chemistry. So I am trying my best to make sure they are accurate. How do you have time to shower while making weekly uploads? What do you mean shower time? Of course I have time to shower. Listen, if I didn't shower and didn't think about this, it would take me like 2 hours to make these geometry nodes. Because now we're done, that's it. We can just assemble whatever we want out of these. We can just add in however many points we want to represent the electronegativity. I am so happy with this. This is great. To be an expert is to write a groundbreaking book or paper. That's your definition. I feel like that's too high of a standard. I feel like for that person we have another term, and that term is called someone who wrote a groundbreaking book or paper. I consider experts people whom I can rely on with information. Okay. Oh yeah, another thing. We would like some software to simulate them. Molecule polarity simulator. We would like something. Molecule polarity, bonds. Colorado! EDU! I'm all for it. Would you... that doesn't look like what I'm looking for. Molview? Oh, wait, does Molview have that? There is no way. There is absolutely no way. Polarity. Oh yeah, that's for protein. I'm an idiot. Those are important. Speaking of, I'm right now just talking flame. Damn, this music bangs. Thank you. Making it more funding for new keyboard because he's breaking this one soon. Funny enough, this is actually the cheapest keyboard. That's the origin behind this keyboard. Engine, Jimo came to do. Would there be? I beg you. Would there please be a polarity thing? Stay on the more came to do. Avogadro gets the polarity of a molecule. Viewing electrostatic potential maps, yes! Oh yes! Create surfaces. Electrostatic potential. Oh, hell yeah! You can do it in Avogadro. Oh, I have Avogadro. Oh my goodness, thank goodness Flame convinced me to get Avogadro. I'll show you everyone right now why Avogadro is probably the coolest, the absolutely coolest chemistry software you can have. Add in a carbon, add in another carbon, add in a third carbon, pop in 2 fluorines for good measure, just to showcase that would work exactly. And on the other side, why not a hydrogen in each molecule? I mean, oxygen in each molecule, and maybe just extend the carbon chain by 2 and pop in a good nitrogen for good measure. There we go. You can make a molecule like this. Now, how did you make the surfaces? Extensions. Create surfaces. Electrostatic potential. Calculate. What? Is it because I didn't simulate it? That might be it. You can start the simulation and it will just figure out the molecule. There we go. Can I create the surfaces now? Electrostatic potential. Calculate? Not yet supported. What do you mean not yet supported? Very low? What do you mean not yet supported? How? What am I supposed to do to have them supported? That just screwed up my mouse. Come on. It calculates the forces. Exactly! That's what's so awesome about it. I absolutely love Avogadro. Make it via hands you can... Because blend the sims in real time 3D. Because it's... Because it's expensive. Free, you know, just VR glass. Hold on. Right here. Right. Let's never created. Okay, what if they haven't been? Extension menu, create surfaces. I see, okay, so I see the pickle. Create surfaces. Electrostatic potential surfaces. Alright. The surface type to Van der Waals, set the color. Okay, so Van der Waals, calculate. Color by electrostatic potential. Oh. Success, everyone! We did it! We have one program which can simulate molecules for us, and then we have another program in which we can do it except in a more cinematic way, which means right here we can simulate whatever we want, and right here we can then modify it to graphically represent what's happening. Isn't that lovely? Isn't that great? The power, the might of the entire universe at our finger. That's it. That's all I had to do for chemistry. I don't know what else to do with chemistry. I guess we're moving on to quantum mechanics. Alrighty then. Wait, oxygen in this case is even more... That's curious. That's why... Huh. Oxygen has an even bigger impact than... Well, I guess it's not really the oxygen, only the fluorine is probably pulling away all the electrons from the inside. Yeah, that's probably it. Oh well. Discard. We can also turn you off, and we can just move on to other stuff, like for example... Hi there, Rashad. Welcome. Actually, should I go for organic chemistry? I did say quantum mechanics, didn't I? My muscle memory just instantly went into organic chemistry. Are those libraries free? Yes, they are! This is LibreText, my favorite source of information. I'm so sorry the day is covering it, isn't it? LibreText.org, the best source of information. I use it for all my research. Successfully caused me to open Blender. I do have that effect on people. Alright, alright. So what should we do, everyone, actually? You know what, let's do a democracy. Let's do a democracy and ask what should we do right now. What shall we research? Question mark. Oh, my Firefox is just dying at the seams. Okay. Quantum mechanics. Or, option B, organic chemistry. I'll just sit back and relax in the meantime whilst you're all voting. Why is play the finals not an option? That's a good question. I mean, I could if you want to. But quantum mechanics won with a landslide. Oh, never mind. It's going down. Engage quantum mechanics. Can you explain Schrodinger's equation visually? It's not difficult. I mean, depends on what you mean explain visually. Because Schrodinger's equation, the meaning behind it, it's really simple. It's the mathematics that's really difficult. Schrodinger's equation. So, if you want to understand what Schrodinger's equation means, that's trivially simple. That's because it's just kinetic energy plus potential energy. So basically, change of the particle equals kinetic energy plus potential. However, if you want to understand why all of this is there, then that's a big backstory, and there really isn't that nice of an analogy. It's mostly just the results of theories, I would say. Can you do 3 round stuff for mathematics needed for it? I mean, that's kind of the purpose of the quantum mechanics video next week. Well, this week it's mathematics, next week is quantum mechanics. That's the purpose of it. So Fitzpatrick. Quantum mechanics, 77%. Alright, now I do believe that wave packets where we at, right? Just... Okay. If we go through this page, that's great. That's phenomenal. That's lovely, amazing, wonderful. So, a big ol' sip of coffee. And let's get to it. Okay. Let me just get a good stretch in before, and here we go. Does time dilation occur with gravity or motion? Because boson have to travel great distances within the system to do chain interaction, and the rate of change of interactions is timed as slowing it. Does time dilation occur with gravity or motion? Because boson have to travel greater distances within the system to do changes / interactions. I don't know how it affects the virtual particles, I'll be honest. I don't know if it's different for virtual particles, so I can't say myself. I'll be here if you make it, don't worry, alright. The previous discussion suggests that wave function of a massive particle of momentum p and energy E moving in the positive x direction can be written as this. Which is really simple, this is just wave. That's it, that's just a wave, that's the normalization factor if I remember correctly. Where k is p divided by h bar and omega is E divided by h bar. Sweet or both greater than 0, makes sense, obviously. Here, omega and k are linked via the spectrum relation, which represents a plane wave through the maximum minima propagate in positive x direction with phase velocity. Everything so far is pretty simple. As we have seen, the phase velocity is only half of the classical velocity of a massive particle. Right. From before, the most reasonable physical interpretation of the wave function is that the square, so the conjugate, complex conjugate wave function is proportional to probability density of finding particle at position x at time t. That's what I want to figure out. Why? Why is it? However, the modulus squared of the wave function, which depends on neither x nor t, in order this wave function represents a particle that is equally likely to be found anywhere on the x-axis at all times. Hence, the fact that the maximum and minimum of the wave function propagate at phase velocity does not correspond to classical particle velocity does not have any real physical consequences. Oh no, hence the fact that maximum and minimum of the wave function propagate at phase velocity that does not correspond to classical particle velocity does not have any real physical consequences. Kinesis. Photons travel every possible path at the same time. How does the movement of photon doing everything at the same time not require energy? That's wave-particle duality, I'm pretty certain what you're referring to. So basically they act as a wave. Both needs boson to move within space to influence fermions. I don't know if that's true for virtual. I've never seen it referred that way with virtual particles. I've never seen virtual particles put in that kind of light, pun intended. This is the place for big brain people. Oh, Goku! Thank you, Goku! Thank you, Goku! It's not actually that big brain, it's just big words, but it's all relatively simple. Well, I mean, to be fair, I'm trying to understand myself and struggling, so. How can you write the wave function of a particle that is localized in x, that is a particle that is more likely to be found at some position on the x-axis rather than others? This makes sense. When we see particles in our universe, we usually don't think of them as existing everywhere equally. We can achieve this goal by forming a linear combination of plane waves of different wave numbers, or in other words, this. Okay, what does this mean? This is psi of k. So wave number here represents the complex amplitude of plane waves of wave number k in this combination. Ah, where's Reblax when you need them? One and only grabbed an hypothesizer. Alright, Ashad, bye, have a good one. Here, psi of k represents the complex amplitude of plane waves at wave number k in this combination. Okay. Complex amplitude of plane waves at number k. Well, we should go back a couple of pages where it was actually defined to contrast the definition of it. I do believe it was photoelectric effect, quantum theory of light. It might have been this one, actually. It was really early on when we switched the wave function around. There we go. I do believe that might be the equation we're looking for, isn't it? Certainly looks like it. XTRT. Yup. Okay. So, Main advantage of the complex representation of a more straightforward real representation is the form enables us to combine the amplitude A and the phase angle V of the wave function into a single complex amplitude. So that's what it is. Complex amplitude, right? And this is complex amplitude of plane waves of the wave number k. So right here, what we're doing is we're combining it this way. Why would wave number... Wait, what? How would wave number k change this? Oh no, oh no, no, no. Oh no, no, no. Let's visualize it graphically. Maybe that will help. Basically, what we have there is we have a cos kx plus phi. And well, as we change the k, these shrink. Odd Kid 2, that's one of my favorites. What would the sum mean? Hold on. Integral from negative infinity to infinity dk, actually dx, dk actually, of psi, so psi of k. So this... Yeah, see, no, that's not quite, is it? Let's visualize Pokemon like a true YouTube math teacher. Oh no, this stream has been Gregified. Why does wave function collapse only when you observe? It's just another way to say we can only know about the electron for sure when we see it, as it's probabilistic. I haven't gone that far, Gemma, I'll be honest. I love your recent video decoding molecules. I was actually trying to learn organic chemistry a few hours before. Your video helped me understand some topics nicely, such as catenation. I am glad I helped. I really am. Actually, soon I'll be making more organic chemistry videos. This live stream, in fact, we started by making geometry notes, which would help me out visualize them. This will be important for electronegativity. What does it mean when it's observed? That's what always pissed me off, because I never quite got what it means observed, for particle to be observed. Or rather measured. I have seen measured being used more than observed. But measurement was always really loosely defined. It seems like when it interacts with anything. And I do mean anything. That counts as a measurement. Which I mean makes sense, but at the same time it's really... Is that the pi bond thing? Well, that was just two different p orbitals, but that was just a template I've used to make geometry notes. Wave function of a particle as localized at x, this particle markedly being further. So we add together... Okay. This is an integral in relation to k, which means what we do here is we add together all the different k's. And oh my goodness, it makes sense! It might. It might make sense. No matter how much we change the k, this will be a 1. This might make sense. Oh, it's not easy to understand, I'll be honest. Oh no, wait, because we're adding from negative infinity to infinity, never mind. Never mind, I'm still lost again. But that's still x, so it means... It's a function of x, but that's the integral. In writing and physics, we are allowing the atomic particle waves as superposable, that it's always possible to add. Where's Remco when you need him? Remco left at the worst possible time. Hold on. Remco, how busy are you? Do you use Blender for your animations? Yes, I do use Blender for my animations. You can just ping if you know. That's what I did right now. I'm asking how busy Remco is. When the world needed him most, he disappeared. Yeah, I mean, really. I don't know if this would be more Remco's domain, because, I mean, this obviously is Remco's domain. But the question I'm looking for... Hi, Remco, I don't understand. I don't understand how you could combine wave functions to gain a wave function that, you know... How you can combine waves to get a wave function that actually, when squared, gives you the probability of particle being in different spots. I don't understand this witchcraft. It makes absolutely no sense to me. He went to search for the graviton. So basically, what I'm wondering is... Like, hold on. Paint. When in doubt, paint it out. Add planes and squared. Yeah, I know, but why? Because in my head, I may be coming off here, but in my head, we have wave functions which look like this, right? And it's just an infinite wave like that looks like this. And then you just... How do you get from here? Like, what's the logic behind... Wait, no, I don't understand. I know it's there, I just don't be clicking for me. Yeah, but if you square an complex wave function, right, like this, if you square it complex conjugate, what you're gonna end up with is, if I'm not mistaken, I'm completely eyeballing it at this point, but you're just gonna end up with a function like this. And that's not really useful. Because plane waves are solutions of the Schrödinger equation. Then sum of two solutions of a differential equation is also a solution of this differential equation. So... So hold on. So plane waves are the solution of the Schrödinger equation, and this way we're basically adding them on together. And a combination of plane waves with different wave numbers. So what happens when you integrate all the solutions of the Schrödinger equation? Because this right here, so far, is just a cosine at the end of the day. You get a constant. Oh. And what does this constant mean? Get a vector. What does this vector mean? It's a vector in the Hilbert space. It represents the state of a system. Okay, I have so many questions. First of all, why do you get that from just adding together all the solutions to, because that's what this is effectively doing, right? It's just adding together all the solutions to the Schrodinger's. So why would adding together all the solutions of a Schrodinger give you, well, anything? Like, what does it actually mean? Okay. Before induction programming waves. Fourier transform of function, because the Fourier theorem to find the k-space function generates any given x-space wave function. Oh wait, so this just changes the, I mean that makes sense what Fourier transforms do. Hold on, so right here you can get the other bar. For instance, suppose the wave function takes of our particle takes form this. Initial probability density of a particle is written this way. Right, okay. The particle probability is pretty Gaussian distribution. Oh my goodness, okay. It's known as Fourier transform of a function. You can Fourier theorem to find the k-space function psi k that generates any given x-space wave function. So right here we're basically switching it up. So add all the contributions to paths, and also the experiment, add up all the plane waves to both slits to get the total wave function. Suppose that. I'm sorry for not talking much, but I'm just really focusing on this for some reason. In complex number of plane wave number k and combination running previous group, we are allowing the assumption of biconstruction proposal that is always possible to have two valid solutions form a third valid solution. Makes sense. The ultimate justification for this assumption is wave particle is that particle waves satisfy a differential wave equation that is linear in psi. As we will see in section 115, this is indeed the case. Incidentally, a plane wave that varies as exponent of, okay, and has negative k but positive or propagates in the negative x direction phase velocity. Hence the superposition includes both forward and backward propagating waves. There's a useful mathematical theorem known as Fourier's theorem which states that, I'm familiar. For instance on the function, we use Fourier's theorem to find the k-space function that generates any given x-space wave function at a given time. So right here we have wave function, which is dependent on the wave, effectively the wavelength. From that we can get the other one, which instead of the wavelength is an x space based on the wavelength. Or rather the function itself is the x space. If it can be seen in measurement of particle position, there's likely value choose. Unlikely value which differs from 0. Yeah, that's Gaussian. Okay, so we start with this equation at time 0, whatever. Okay, hence we can employ Fourier theorem to invert this equation to give. Yup, that makes sense. Making use of equation, we obtain this. Now, what does this mean? Well, this is just the equation. Okay, sweet. Changing the variable of integration. So right here, just solving the integral. Where beta is this? Okay. The integral just reads number can be easily seen by making change of variable, and we obtain this. Where this? If size proportional to probability density of measurement, but that's that assumption feels kind of off. I have read through this book so far. I've never seen a wave function being referred to as proportional to probability density. It's always just been a wave. Where does this come from? I don't get it. The Schrödinger equation is the equation that tells how the system evolves. Specifically, it tells how the state evolve under time. A plane wave is a solution for the Schrödinger equations that we can determine the future of a plane wave exactly with the Schrödinger equation. Yeah, but I still don't get... Where does this come from? And hold on, like, look here. Right here is plane waves before plane waves even. Yeah, plane wave, sweet, wave functions. This is how the wave function is introduced. This. If this square wave function is proportional to probability density of a measurement of the particle's position yielding value x, that's a pretty big if. Marginal state we can consider does not depend on one plane wave, so we can consider all plane waves. Yeah, but where does this if come from though? That's what confuses me so much. I don't get it. Where's this? This is how wave function is introduced. That's just a wave. Why would the square, or rather complex conjugate, by complex conjugate, be proportional to the probability density of a measurement of a particle's position? It's an assumption. Yeah, but you can't just make the wild assumption. In physics, there's always a reason for an assumption. This is a pretty wild assumption to make. Has to be a reason for it. Because, like, the rest is dependent on it, but where does it come from? Might as well look it up. Wave function, then from there, because I can't just do a complex conjugate of a wave function. Probability. The bond rule provides means to its complex probability to the actual probabilities. Seems like something I'll be looking for. Gives the probability measurement constant will yield a given result. One common result is the probability density of finding particle at any given position is proportional to the square of the amplitude of the system wave function at that position. Oh, I see. Well, that feels important, doesn't it? The observable measuring the system with normalized wave function responds to self-adjoint operator who's expecting discrete if. We can expand the wave function in terms of position and coefficient. We can expand the wave function in terms of the position with coefficients. And these coefficients tell us what the position probability of a state is for some position. That makes so much more sense. Okay. Alright, so it's... Okay, that makes a lot more sense. Alright. My goodness, that makes so much more sense. That makes so much more sense. Hold on, let me see if there... missed something on it. That makes such an unbelievably much more sense. The position vector are normalized, the wave functions are normalized. Oh my goodness gracious me. Superimposable, that's kind of, but that's only 2, and that's for double slits. That is not quite what we're looking for, is it? Neurotic style like pushing operators and its eigenvalues. Oh, please don't. I'm gonna get to eigenvalues anyway. To suppose that we allow influence pass through apparatus, that's still double slit, so it might be too specific, but maybe something. Because in front catches effects amount of energy. Well, that's more quantization than waviness, isn't it? Unless it's related, in which case I'll have to go back. Quantum particles, right? Yep. Okay. So, if it's proportional to the probability density of a measurement of the particle position, I really wish there was some link here to tell us where that assumption comes from. But I mean, fine. It's fine, whatever. I can find it myself. It's whatever. But if measured in the system of normalized wave function with self-adjoint with A whose spectrum is discrete. Well, okay. We want eigenvalues A, and then the probability of measuring the given eigenvalue will be equal right here. Okay. Observable measured function. Hi, the coder called it. Welcome. Welcome. What's the server joint? Spectrum discrete, but that's if it's spectrum. I'm an idiot. My goodness. Maybe this is a good time to ask ChatGPT. A single structure's particle can be described by a wave function that depends upon position coordinates and time coordinate. The Born rule implies that the probability density of function p for the result of a measurement particle position time is this. Okay, so that's where it comes from. Okay, good. We've pinpointed the origin of the assumption. Alright, Born rule, sweet. Okay, good. Now all we need to do is expand on it. And the main idea is the wave function psi can be rewritten as the sum over x of xi, and the xi are real numbers that serve as probability when modulus squared. X is the state in position x. Oh, hold on, I have to reread what you just said because that was not English. The main idea is the wave function can be rewritten as the sum over x of this. Okay, so sum over x of this, and the xi are real numbers that serve as probability modulus squared. Okay, hold on. I think I kinda get it, but I would still rather just do it here. Wave function that can be written as the sum over x of this. These serve as probability when modulus squared. Okay, no, but my question is, why do they serve as probability when modulus squared? That's my question. Why do they serve as probability when modulus squared? What are you trying to know? I'm trying to understand why this relates to probability. I could just go into the Born rule, I guess. Details. There's that observable measures. Because they're trying to create discrete measures. All will be the eigenvalue's probability of measuring given eigenvalue will equal this, where the projection of the eigenspace of A corresponding to in this case eigenspace A squared. complex number is known as a probability amplitude. Feels important that the state vector is the eigenvector. Probability is equal to amplitude squared. Okay, we're getting somewhere. If it doesn't, we are not interested in the psi. Kind of force it to be normalized. Devil's probability. Okay, you can see why I'm not satisfied with that answer, right? So since the complex number is known as a probability amplitude, the state vector assigned the eigenvector, this one is going to describe bond, I would say. Okay, so we take... So this right here, probability amplitude. I'm getting closer and closer to the answer. In quantum mechanics, probability amplitude is a complex number used for describing the behavior of the system. Okay, so so that's where it comes from. It's not that the probability amplitude describes probability, it's more like the probability is described by the probability amplitude, right? Is that right? Am I getting it? I don't know if I'm getting it. I don't know. Why is the I in your YouTube name not a capital letter? That's a long story. And that's coming from someone who's just gone rabbit hole into probability amplitude. I don't know if I'm getting it. I would really like a confirmation if I'm getting it or if I'm not getting it. That's such a... Okay, well, I mean... I don't get the connection, I won't be lying. I do, even if I'm right, I don't get the connection. Because this assumption still feels... Well, it doesn't feel quite as odd in this case, but it feels odd in this case. So now if I'm right, and that's a big if, then I would have to connect this to this. The wave function that exists in real life are those that have associated probability amplitude, so we only investigate that. But why? Why do wave functions that exist in real life are those that have associated probability amplitude? Such as psi is always normalized. Okay, so we just defined it in a way so that it's just... they always fulfill that requirement. Because we can measure them. Okay, why would our ability to measure them... okay, so we just defined them this way. So we just said that... Probability state. Okay, so we just defined them this way. That's the reason. We just defined this as the probability amplitude. And so we said that it's... when multiplied by its own complex conjugate, it gives us this. Yes, okay. So now that the if has been fulfilled, time to connect it to... That's... time to connect the two dots together. How hard could it be? In the case where the eigenspace, because when lambda is one-dimensional, it's found by a normalized eigenvector. The probability is equal to this. Since the complex number is not the probability eigenvector, we're going to describe bond rule, saying that the if is just that if we deal with a state that could happen in real life. In case of spectrum A is not only discrete, the special theorem the extent of a certain projective valued measure, spectral measure of A in this case. Probability that the result of a measurement lies in the measurable set is given by... Okay, so in other words, wave function multiplied by its own complex conjugate is proportional to the probability of finding a particle in any given spot, because if it wasn't, then we wouldn't be able to measure them, And if we are not able to measure them, then we don't actually care if they exist or not. Okay. So now that that tangent is over, we can get back to it. Oh, this is fun. This is certainly fun. This is certainly fun. Coded. I don't know if you sent any links, but links don't work in YouTube chat. YouTube isn't letting any links through. So I know you've sent a link, but that will not work. Welcome to physics. Okay. Cool, that's great. Thank you, Remco. That helped. That certainly helped. The proportional probability density of measurement of particle precision yielding value X, and it stands to reason that semi-k is proportional to the probability density of the measurement of the particle wave number yielding the value K. This makes sense. This makes simple sense. So basically, it's the same rule, except instead of doing it with position, we do it with a wave number. Neat, nice, festive, phenomenal, fantastic. Fantastic. Recall that P is equal to 8 bar K, so measurement of the particle's wave number is equivalent to the measurement of the particle's momentum according to the equation. Note that this probability distribution is a Gaussian K space, hence a measurement of K is most likely to yield a value K0 and very unlikely to yield a value which differs from K0. More than 3 delta K. Incidentally, a Gaussian is only some mathematical function in X space that has some formula for it. Okay. The only simple mathematical function X space. What do you mean simple? No, sorry, that's not what I meant. That's not what I meant to click at all. How will you explain this in a 10 to 20 minute video? I mean, the thing is, that's precisely what I'll say. I'll just say that that the wave function squared, that the wave function multiplied by its own complex conjugate is proportional to the probability, because if it wasn't, then we wouldn't be able to measure it. And if we were not able to measure it, then that's kind of like saying that the particle doesn't exist. It's the age-old question of if a particle interacts with nothing, then is that actually a real particle? And in this case, we're just assuming that it's not. So that's actually pretty simple to explain. It's just getting there is the biggest issue. It's not about the destination, it's about the journey, you know? So if you can't see it, it doesn't exist. It's more than that. If you can't interact with it, it doesn't exist. Because if you think about it, there is no difference between things that aren't real and things you can't interact with. Even if it does not interact, it does exist. It wouldn't matter from our perspective. And our perspective, I don't mean just humans, I mean from the perspective of our universe. If you have a particle in our universe that doesn't interact with anything, then that's equivalent to that particle not existing. So there is no difference between the two. Ah, makes sense. That makes a lot of sense. Okay, now it's probably distribution of Gaussian K space and the measurement of it. Yeah. So the Gaussian probability distribution of characteristic with the in K space. Is that the uncertainty principle? Probably wave packets in which contract pi is very localized in X space. We need to combine plane waves with a very wide range of different K values. We need to combine different small the resulting wave packet will extend in X space. That's the uncertainty principle, isn't it? There's a limit on the position, the momentum. Oh, actually, anything dependent on position and anything dependent on the wave number, I suppose, rather than position and momentum. Okay. Oh, I feel powerful. We have seen an equation how to write the wave function of a particle that is initially localized in x space. Let's examine how the function evolves in time. According to the equation we have, yup, cool, where this, don't care. The function is obtained by Fourier transforming the wave function at t equals 0, and according to the equation, strongly peaked around k equals k0. Makes sense, Gaussian. Thus, it is a reasonable approximation to Taylor expand. Keeping terms up to second order, we obtain whatever, cool, neat. Where this with, yeah, fine, more characters, derivatives, makes sense. We get acceleration this way. The equation changing was integration to this, where this, okay, incidentally, as the initial wave packet prediction can be rearranged to give this monster, where y is equal to this, I can change the variable to z, blah, 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 we get this, whatever. The integral now just reduces to a number, hence we obtain this thing with sigma squared, right? Not the previous wave function is identical to the original wave function, justify the approximation that we made earlier by Taylor expanding the phase factor. On the equation, the probability density of our particle as a function of time is written this. Alrighty. What knows about particle is that they never interact unless they are under certain conditions. That's why I suppose even though there's no interaction, it still does exist. As I mentioned, Kelvin, if something doesn't interact with anything, then there is no difference between it existing or not existing. It honestly depends on how you define existence at this point. Under most definitions of existence, they wouldn't exist. Anyways, probability 1. Measuring collapses the wave function to stay at which particles measured. So for describing particles with wave functions, we automatically need this probability description. That does make sense. That makes perfect sense. Yeah, if you have probability lower than 1 of measuring particle anywhere, that's where it comes from, isn't it? Is that really where it comes from? That does make a lot of sense. We just have not found a way to make it react to prove its effect. Kelvin, we're not talking about particles which we cannot measure. We are talking about particles that interact with nothing. So if you imagine a hypothetical particle that interacts with nothing, absolutely nothing in our universe, as far as physics is concerned, that particle does not exist. It's not a matter because if it interacts with nothing, then there is no way to make it interact with anything. By definition, it interacts with nothing. The kind of null particle that... It's not even vacuum. Vacuum is more important than this. It's nothing. In that case, sure. Yeah, that's what we mean, basically. Can you represent our universe as a function where every solution is time sum of that equation? I don't think you can, because of the uncertainty principle, if I'm not mistaken. That's the limit on uncertainty. Okay, but make it consider. Consider what? Oh no. Consider what? Oh no. What if particle interacted near the Big Bang, but then decoupled from everything and now doesn't interact with anything? Well, that would mean that hypothetically you can still recreate the environment in which it can interact with something, which means that particle can interact. Unless you're suggesting that there is no symmetry and it decoupled and then cannot be recoupled. In which case, yeah, I would say that the particle ceased to exist. Because if it cannot be recoupled, then there is no way to make it interact with anything, pun intended. Decouple symmetry. Oh, if you decouple, you cannot recouple? Really? That's really not possible. You mean tell me that I can't give photons mass even if I believe in myself? Even with the power of friendship, I wouldn't be able to give photons mass? Has to be a way. You're just trying to justify gravitons, aren't you? Oh no, I swear that yeah, they have no color charge, no electromagnetic charge, they don't interact with the weak interaction, but I swear they still exist. Making somebody ignoring my jokingly misogynistic sentence does not get demonetized. I was busy making fun of gravitons. It's always more important. Making fun of gravitons is always top priority of my list of priorities. Besides, I know you're joking. It's fine. Busy ignoring gravitons. Gravitons are just liberal propaganda. That's what they are. Probability density of a particle as a function of time is written. Is that in any like, hold on, is that for all particles? Are all particles Gaussians? I need specifics. Is it for all particles or if it consider if it's a Gaussian? Suppose that the wave function of a particle takes form. That's the problem. It's... Damn it. I hate it when things are vague this way. So it's not always. It's... If it's a Gaussian, then it's a Gaussian. Cool. Geonode for water. That's cool. The probability density of our particle as a function of time is written. But that's not every particle, is it? It's our particle. Because in the last chapter, we just assumed it to be a Gaussian. Cool. It's a Gaussian. Characteristic with the peaks. The most likely position of a particle resides with the peak of the distribution function. That's the particle most likely position is given by this. Hold on, though. Right here, we start with this assumption. Are we taking any other additional assumptions? No, this is just an exponential. Never mind, this might be a chapter that actually proves it that every single one is a Gaussian. Okay, that seems normal. And so we obtain this. This wave function, 245. I mean 245, this one. I don't think that's a link. Okay, 245. Uh-huh. That doesn't feel like it. You have a Discord channel for Blender? We do not, but we do have artist channel, I think. Just art channel. Or promote yourself, whatever. There's a couple. The probability is 60 million pixels. Uniform velocity. A plane wave travels at the phase velocity, whereas a wave packet travels at group velocity. Oh, I see. I put it in general. Let me see. Oh, that's cool. Oh, so you did what I was trying to do, except more rigid. That's neat. Where's that lightning thing on the top? Localized in the region atomic scale, then the doubling. The width of our wave packet grows as time progresses. Indeed, it follows from the equation that the characteristic time wave packet of original width delta x to double in spatial extent is this. Have an electron origin localized in the region of atomic scale, then doubling time is only about... Oh, that's small. So wait, is just the electromagnetic charge keeping it in place? Is that it? Alright, well, I feel like that would be it for this live stream, because I'll be honest, I'm spent. This was a lot for me. Like, we haven't done much animating work, but it was a lot of mental effort. So I'm gonna go now, eat something, then get back to actual animating work. Hopefully finish scripting the math video. That's power save for auto-saving when you ask your PC to render a few billion triangles and explodes. That's pretty clever. Isn't even 100 minutes. Mate, it's been 90 minutes. Well, not 90, it's been half an hour of really quick geometry node making, and then an hour of quantum physics, alright? I've deserved the rest. So I'm gonna finish scripting the math video. I'm gonna hopefully finish the first chapter and maybe start the second chapter of the math video. And for now, that'll be it. Thank you everyone so much for watching, and have a great day. Bye.